Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss Laplace transform of unit step function, Dirac delta function and periodic functions. Let's begin. First, Laplace transform of unit step function. What is unit step function? First, we have to define unit step function. The unit step function that is defined as u of t minus a, which is known as the unit step function. Its value will be 0 when t is less than a. The value of t when less than a, that unit function results 0, and it will be 1 when t is greater than a. If we plot the graph graphically, here t, here we represent u, that axis, unit function, step function at point A, the graph looking like this. When t less than a, here the unit function, unit step function results 0, and when t is greater than a, that results 1. Now, Laplace transform of unit step function. Is given by Laplace transform of unit step function u t minus a. From the definition of Laplace transform, the integration from 0 to infinity e to the power minus st, that given function u t minus a dt. We change the limit from 0 to a and a to infinity. So, the limit change from 0 to a e to the power minus st u t minus a dt plus limit from a to infinity e to the power minus st u t minus a dt. When that limit from 0 to a, that value as 0. So, in place of u t minus a, when the limit 0 to a, we put 0, and when the limit from a to infinity, then that value of unit step function is 1. Here we put 1 in place of u of t minus a. The values are put 0 to a e to the power minus st 0 dt plus from a to infinity e to the power minus st 1 dt. That integral vanishes as a 0, only that integral exists, and the integration can be solved as e to the power minus st divided by minus s, and that limit from a to infinity. So, it is e to the power minus using upper limit and lower limit. So, the minus term as plus. So, e to the power minus s a divided by s, which one is the Laplace transform of unit step function u of t minus a. That one is the Laplace transform of unit step function, and that unit step function is given as u of t minus a is equal to 0 when t is less than a, and that unit step function value is equal to 1 when t is greater than a. That is the graphical representation of unit step function, and it is denoted by u of t minus a, and its Laplace transform results as e to the power minus s a divided by s. Next, Laplace transform of Dirac delta function. When we represent a function in terms of Dirac delta function, as if first we consider if the function f of t is continuous and integrable, then the integration from minus infinity to plus infinity f of t delta t minus a dt is equal to f of a. That is a property of Dirac delta function, which is known as the filtering property. It is the filtering property of Dirac delta function. Taken as equation number 1. If here we substitute f of t as e to the power minus st, if we substitute f of t is equal to e to the power minus st in equation 1, we get similarly the limits also change as minus infinity to plus infinity changed as 0 to infinity. So, the limit change from 0 to infinity e to the power minus st in place of f of t as e to the power minus st into delta t minus a dt. That integral can be solved as e to the power minus st at t is equal to a, it result e to the power minus s, that is equation number 2. But that integral 0 to infinity e to the power minus st delta of t minus a dt can be written as integration from 0 to infinity e to the power minus st. Let again del of t minus a as a function f of t dt, where we use f of t as delta of t minus a, that is the definition of Laplace transform as the Laplace transform of the function f of t. So, that can be written as integration from 0 to infinity e to the power minus st delta t minus a is equal to Laplace transform of f of t. That is equation number 3. When we compare equation number 2 and equation number 3, okay, integration from 0 to infinity e to the power minus st delta t minus a is equal to, in place of f of t, as we substitute delta of t minus a. So, Laplace transform of delta of t minus a, that is equation number 3. So, comparing that equation number 2 and 3. So, the value of Laplace transform of delta t minus a is equal to e to the power minus a s. Comparing equation 2 and 3, equation 2 and 3, we get Laplace transform of Dirac delta function t minus a, result as e to the power minus s a. For a special case, for a is equal to 0, Laplace transform of delta of t is equal to e to the power 0, that value will be 1. Again, for a is equal to 1, Laplace transform of delta of t minus 1, in place of a we substitute 1, that is e to the power minus s. E to the power minus s is equal to 1 divided by e to the power s. Laplace transform of delta t, Laplace transform of delta of t minus 1. Here we show the Laplace transform of Dirac delta function, which is resulted as e to the power minus s a. Next, Laplace transform of periodic function. Periodic function we know as, what is periodic function? If a function f of t is said to be periodic function of a period capital T, means after that period t, capital T, we have the same value of that given function, f of small t plus capital T is the period t, then we achieve the same value of that function f of t, provided that the t must be greater than 0, which one is positive. So, the graph of that function f of t represents itself after every interval of the period t. Therefore, that function f of t is said to be a periodic function. If that given function is periodic, then what should be the Laplace transform of that kind of periodic function? Laplace transform of f of t, which one is a periodic function of period capital T, is equal to the limit of integration from 0 to capital T e to the power minus st f of t dt divided by 1 minus e to the power minus st capital T, which is in the period t. Now, we prove that expression Laplace transform of the periodic function Laplace transform of f of t. From the definition of Laplace transform, integration from 0 to infinity e to the power minus s t f of t dt. Since f of t is a periodic function, so the limit can be changed just like integration from 0 to t e to the power minus s t f of t dt plus integration from t to 2t e to the power minus s t f of t dt plus integration from 2t to 3t e to the power minus s t f of t dt, and it continued so on. We have to substitute. Let us put in place of small t as u plus capital D. In the second integral, and u plus 2t in the third integral, and so on. So, the Laplace transform of the function f of t is written as integration from 0 to t e to the power minus s t f of t dt. Here in place of t we substitute u plus capital T. So, integration from 0 to t e to the power minus s as u plus t du du, and the limit of integration from 0 to t plus 0 to t e to the power minus s u plus 2t f of u plus 2t du plus dot 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 is equal to integration from 0 to t e to the power minus s t f of t dt plus e to the power minus s t integration from 0 to t e to the power minus s u f of u du plus e to the power minus 2 s t integration from 0 to t e to the power minus s u f of u du plus dot 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 as f of u is f of u plus t, that is a periodic function f of u plus 2t. That is why 0 to t e to the power minus s t f of t dt plus e to the power minus s t integration from 0 to t e to the power minus st f of t dt. As we substitute, u is a periodic function having the period t, plus e to the power minus 2 st integration from 0 to t e to the power minus st f of t dt plus dot dot dot. In all these terms, taking the common, integration from 0 to t e to the power minus st f of t dt, 1 plus e to the power minus st plus e to the power minus 2 st plus dot 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 up to infinity. Taken common, integral term 0 to t e to the power minus st f of t dt. That type of series is written as 1 divided by 1 minus e to the power minus st integration from 0 to t e to the power minus st f of t dt, where we use the formula as 1 plus u square of 2, we have 1 divided by 1 minus u. As we have Laplace transform of f of t is equal to that much, then Laplace transform of f of t, just write it, 0 to capital T e to the power minus st f of t dt divided by 1 minus e to the power minus st. And the Laplace transform of a function f of t which is a periodic function having the period capital T. So, with the help of this video lecture, we understand Laplace transform of unit step function, Laplace transform of Dirac delta function, and Laplace transform of a periodic function and its proof. So, with this useful and informative notes, let me wind up this session. Thank you.